Okay, this is Math 2, and finally we're in the last video for the homework section. We're doing 45 to 47. The first one says, decide how many real solutions each equation has. Explain how you know. You may not need to solve the equation. So, the first one should have a solution. You should be able to solve this and find the value of x. So there's one real solution on this one right here. This one, if you try to solve it and take the square root of both sides, you're going to end up obviously with a negative under the radical sign. So it doesn't have any real solutions, but it does have solutions. They're just actually imaginary numbers. And then this one should have two real solutions actually. So you have 3x squared. So we're going to add 18 to both sides. So we have 3x squared is equal to 18, divide by 3, divide by 3. So we have x squared equals, please notice that there's no x in here. There's no like 3x squared minus 6x minus 18 or something like that. It's just an x squared, and that's the only variable that you have, which is why I'm allowed to do this. 18 divided by 3 is 6. So when you take the square root of both sides, you should get x equals plus or minus some decimal. So that means you have two real solutions. They may not be pretty, but they are real solutions, unlike part B, which was imaginary. And then D is never going to happen, pretty much. You have x, some number minus 6. When you take the absolute value of that, you're going to get a negative 7. Okay, well, that's just never going to happen. The absolute value of anything that you ever put in here is never going to come out to a negative number. So no solution is your final answer because it just will not exist. No, you can try as much as you want. You're never going to be able to tell me you're going to put a number in here and then you take the absolute value of it and you get a negative 7. Since we're actually talking about a distance, distances are always positive. It's never going to happen. That was 45. 46. For each solution below, decide if A is greater, B is greater, if they are the same, or there's not enough information. Oh, well, this is silly. Okay. Really? For real? A is the measure of a central angle of an equilateral triangle. B is the measure of an interior angle of a regular pentagon. Oh, that's just weird. Central angle of an equilateral triangle. Okay, well, here's an equilateral triangle. All the sides are the same. All the angles are the same. So I guess they're all 60. It's a central angle. So I guess it'd be like, I'm changing the zoom right now. Hold on a second. There you go. That's a little bit better. Well, that's, am I even cutting that in half? Yeah, I am. So that's 30. That's 30. So if this is 30 and this is 30, 30 plus 30 is going to give me 60. 180 minus 60 is 120. So I guess all the central angles are 120. Oh, which makes sense because 360 divided by 3 is going to give you 120. Okay, so A, I guess, is 120. B is the measure of an interior angle of a regular pentagon. Okay, so pentagon, pentagon, pentagon. Okay. 5 sides, so 5 minus 2 times 180. So 3 times 180, 540 divided by 5, because it's regular, is 108, 108 degrees. Okay, they're not the same. Interior angle of a regular pentagon. So almost, but not, actually not really almost at all. So that's 108, that's 120, so they're not the same. Part B. There is not enough information to go by to say that they're equal. If you knew that this line and this line actually had a marking on it which told you they were both parallel and obviously going in the same direction, then you can definitely say A and B are corresponding angles and then tell me that they are equal, but they're not equal. Well, you don't have that they are parallel lines, so you can't say that they're equal. A is greater or B is greater? No, there's just not enough information. I don't know what they are. Or in this case, 120 is greater, or in part A, it was 120 was greater than B. Okay, here. We do have enough information. We can definitely do this. So this is 12, this is 8, right? So let's see, 8 squared plus, I don't know, I just call it x for lack of a better, equals 12 squared. So 144 minus 64, that's going to give me 80 for x squared. And the square root of 80 is 8.9. So somewhere around 9, let's just say. Okay, so if this was true, then which one of these angles would be bigger? And this actually comes from, was it the first chapter or the second chapter, somewhere around there in the book, where the bigger angle was actually across from the biggest side. So in this case, angle 90 here is always going to be across from the hypotenuse because the hypotenuse is your longest side, or the biggest side. And then 8 and 9 would then have to mean that 8 being the smaller side is across from the smaller angle. Small angle. And then B would have to be then the medium angle. So that means they're both going to be smaller than 90. It doesn't matter which one. But the big one is, or the significance is that B is going to be bigger than angle A, no matter what the situation is. Okay. The next one. A equals B plus 3. What? Okay, well, technically, if I subtract B from A, then I have that A minus B is equal to 3. Okay, well, what does that tell me? A minus B equals 3. Well, it pretty much tells me that A has to be a positive number. Can't be a negative. Okay, that's true. So A cannot be negative, because if it was negative, if I subtract a negative number from any number, I have to have a negative as a result. So you can actually see that, because if I have like something like negative 5 minus 2, right? That would give me a negative 7. And I know 3 is positive. This is just like an example. 3 is positive, so that would mean that A has to be a positive number, and it has to be more than B, because if it wasn't, let's say you had 1 minus 4. Well, 1 minus 4 is a negative 3. That's going to end up being a negative, and we really want a positive. So a positive number, and B is still a positive number, right? So let's say 4 minus 1. Okay, well, that'll give me 3. But what if B is negative? Well, it wouldn't really matter anyways, because if B was negative, it'd still be less than A, because kind of like 4, oh, that would never, so kind of like 1 minus 2. That'll give me a 3 also. So, but then 1 is always going to be more than negative 2. So in this case, A is always going to be more than, can it be equal to? I don't think so. I don't think so. A is probably going to always be more than B. And I don't think they're equal. Oh yeah, no, they're not equal. If they were equal, if A was equal to B, like 5 and 5, or 3 and 3, or 1.5 and 1.5, it'd be 0. So they're not equal to each other, that's for sure. Okay, C. It's not E, not C, sorry, E. Okay, that's weird. So 90 minus 23, 67. So that's 67 degrees. So this is the small side. And the question is it smaller than whatever 67 degrees might be? That's 23 degrees. That's 7. These are the same. A and B are equal. Oh, same side. Same value. 23 is across from B. 23 is across from A. The hypotenuse is the same. This angle is obviously the same. They're the same value. Okay, done. Which of the following cannot be the measurement of exterior angle of a regular polygon? Okay, so let's just divide. 360 divided by 18 is equal to 20. Okay, so this is 20 sides. 360 divided by 24. 15 sides. 360 divided by 28 has 12.86 sides. Okay, that doesn't make any sense. So far it's C. 360 divided by 40 is 9 sides. Okay, so I guess the winner is C again, with 12.86 unimpossible or impossible sides, because there's no way you have 12.86 number of sides. You either have a full side or you don't have a side at all. Alright, that was it. I'll see you guys at school later.